Now in this tangent curve, the directions have asked us, this is example 1 in your book, the directions have asked us to describe y equals negative tangent of 2x in terms of the basic function. Well, the basic function is tangent. So y equals negative tangent 2x is the graph of tangent of x after a horizontal shrink by 1/2 and a vertical flip over the x-axis. So in calculating each of those, for the basic points of a tangent curve, the tangent of a negative pi over 2 is undefined, negative pi over 4 is negative 1, etc. I'm going to take each one of these points and put it through the two transformations in this curve. So the x-coordinate of negative pi over 2 has now been shrunk in half. So that will be x equals negative pi, oops, that's one too many things, pi over 4. Then the vertical flip over the x-axis only affects the y-coordinate, so it's going to stay negative pi over 4. X equals negative pi over 4. I am taking the x-coordinate and multiplying by 1/2, and then I'm taking the y-coordinate and changing from negative to positive or vice versa. So this will be negative pi over 8, negative 1, and this will be negative pi over 8, positive 1. Nothing is going to happen to the center because if you multiply or change from positive to negative, zeros don't change. Let's see, this will be positive pi over 8, comma, positive 1, and then pi over 8, negative 1. And this horizontal or vertical asymptote will change x equals pi over 4. And then again, the vertical flip doesn't affect it. Now I've pre-graphed that for you here. I did not change the scale on my x-axis. I could squeeze in this enough. It's getting a little small. I probably could have expanded out my axis a little bit, but I didn't. Now, the domain values left out here. Well, the two asymptotes we got were negative pi over 4 and positive pi over 4. So then continuing with that pattern, I see 3 pi over 4, 5 pi over 4. So again, you can pick any 3 values you want as long as you show that this is an infinite pattern with your 3 dots in the front and 3 dots in the back. So I can pick pi over 4, 3 pi over 4, 5 pi over 4, dot, dot, dot. The period of a normal tangent curve is pi. Now this has been horizontally shrunk in half, so this is going to be pi over 2, which leaves the frequency at 2 over pi. Now the asymptotes, this is something we didn't talk about on the previous page. Asymptotes, again, are infinite, so you've got to demonstrate that pattern with dot, dot, dot. You can pick the same exact values as your domain, but because it's an infinite pattern, you can pick different values that just fall in that same pattern. So to spice things up a little bit, I'm going to pick negative 3 pi over 4, negative pi over 4, and positive pi over 4. See what I mean? Math is exciting. Now on the bottom right, examples of my end behavior. I chose 3 pi over 4. So here's 3 pi over 4. As we approach from the left, the y values go down to negative infinity. As we approach from the right, the y values go up to positive infinity. Any questions? Just kidding, this is a video, I can't answer questions. Alright, this last page would be an example that you would do in your homework. I've been doing a little bit more work than your homework would require you, just because I want to get as much information out to you as I can. But you are only required to do what the directions ask you in your homework, so that's what I'm going to demonstrate on this problem. Describe the graph of the function in terms of a basic trig function. Well, the graph of y is the tangent of x horizontally shrunk by 1/2. Locate the vertical asymptotes and graph 2 periods of the function. Vertical asymptotes of tangent are at negative pi over 2, pi over 2, 3 pi over 2 when cosine the denominator is 0. So the vertical asymptotes of the tangent of 2x, which is vertically shrunk in half, are at x equals negative pi over 4, pi over 2, and 3 pi over 4. Each one of those values shrunk in half, so they're closer together. Here are my 2 periods of the curve found by the points and asymptotes I got by translating the original tangent values. And I followed that pattern once to draw exactly 2 periods of the function, which the directions ask for.